All right, so we're here with Nick Polivis, who we just call Polly. So if you talk to someone on the phone, his name is Polly, it's him. We've been on a bit of a spring testing journey. We first bought, I got an intercomp spring tester when I bought all of Ballard's equipment in about 2000. That intercomp spring tester was from genuine 1996, and it didn't fit any fork springs bigger than 41 mil, not much use. So I then sent the load cells back to Intercomp in the US, got them to recalibrate and give me new displays, and I did that, and I used that for quite a few years. Then I sold that spring tester to Sean at SOS, just behind us. So Sean bought it. And then I bought a new Intercomp spring tester, and that lasted us for quite a few years. So then we really wanted to get a spring test that was better, something that was easy to use. The Intercomp's very dependent on using a good method. Like, your method has to be sound because there's so much flex in it, it's a little bottle jack, right? It's problematic. And we also wanted to do destructive testing of springs too. So we wanted to cycle the springs until failure, because that's one of the things that we didn't know. How many cycles does it take to make a fork spring fail? How many cycles does it take to make a shock spring fail? Do you have to do them to full stroke or near solid height to make them fail, or does this happen earlier? So we didn't know all of these things and a bunch more. So we actually made our own spring tester, which was a pneumatic. I think I only just threw the cylinder for that in a scrap a couple of days ago. And that was an interesting experiment. It had 3 load cells on it. I'll find some pictures of it. We might be able to insert the pictures of it. And we never really got the positional control on that working properly. It was always an issue. So we gave up on that, and we bought an Andriani spring tester, which we then had to get a new board for it, a new screen, and it was based on
it was based on
an Arduino board, and we then again, we didn't really suit what we wanted to do. So we then looked at every spring tester on the market, and we ended up buying this. So this is a Laba 7. We quite like it. It's quite good. So for something like the job we're doing today, which is the Honda Transalp, it's a great tester for testing both the progressive element of the spring, and sometimes a spring like this will appear progressive, but then in a test it is surprisingly non-progressive. Polly, what are some of the things about this spring tester that you really like?
I do like the simplicity of it. You just load the spring in, that's already done. You can bring it almost up to where it touches. Then you can close it. You don't have to worry about the spring flying off or shattering and hurting you.
So Polly, what is it about the Laba 7 software that you quite like?
I think it's just really simple. It's got everything you need and nothing you don't really need. So, you might be wondering what we do when we get new bikes in, when we've got spring rates that we don't know. Pretty simple. We use our Laba 7 spring rate tester. So it's pretty simple the way it works. We write in the name of the bike. In this case, it's a Transalp and it's the standard fork spring. We set the test travel. Obviously, longer is better, but because it's a long fork spring, you can start to flex and do strange things. So I'm going to keep it to 100 millimeters. We set the max allowable force. That's not too important in this situation, and I like to set the preload to automatic. So it's gonna lift itself up until the spring makes contact, and it'll stop at about 1 kilo, 10 newtons. We click start, and off it goes.
getting caught on something. Because,
On this spring, it looks like it's a progressive spring. It's got some very tightly wound coils at the top, which you would think is progressive. But in the tests, you can see it's actually not. When the spring moved halfway through the test, you heard it go clunk. That's the clunk there, which is not, it doesn't destroy the test. And with all fork springs, trying to test them is actually quite difficult because you have to guide the spring, but without causing any drag. So you're trying to keep the guide away from the spring. The guide has to be a steel guide. We've tried using plastic and other softer guides, but we end up with too much binding, which comes out in the test. So we've found we're better off to have something like this happen, where we have a dip, because we know the spring is moved, and it doesn't really interfere with our overall impression of the spring.